So today we're going to actually talk about one thing I'm going to do is go over the assignment worksheet because the formulas that they give you are, to say the least, confusing. I sent it to Laura to help you guys tomorrow when you meet with her for your tutoring, and she had to look some of them up too because they didn't make sense. So we'll go through that and talk about the structure of those equations that they have and the terms they're using, what those abbreviations actually mean. And then we'll do that though after I spend some time talking about linear and quadratic equations, something that you need to understand at least a little about. We've been linear equations and quadratics have different properties, and there's different ways of solving them. We will not be going into quadratic equations in this class as a problem for solving because as my daughter's math teacher in high school said, much to my annoyance one day, he was an accountant actually, CPA, and had been the chief financial officer of a software company before he went into teaching in the school that they were going to. He said to them, "I don't know why I have to teach you quadratic equations. I've never used one." And I said, "You're teaching them because they have to know them to get into college, to get past their math requirements. So you do have to, and please don't tell them that, then you're telling them not to learn it." But in this class, I mean, to be quite honest, unless you go into a career either as a mathematician or in some of the sciences, you're not likely to have to deal with quadratic equations. So an overall view of what they are, what they represent, and how they differ from linear equations, which is mostly what you'll be dealing with, is useful for you to have. So we will get started there. We have an in-class activity. This one will be similar. It has a worksheet. You guys will work together. Let me caution you not to look at algebraic equations and freak out because they are complicated. But what we'll do is take a look at how you can break them into digestible pieces and solve them. Admittedly, you can use Excel, but in order to make use of Excel to do any of this, you need to understand the basics of what they mean, because just plugging numbers into something, unless you know what they are and why you're using them, is not very useful. And so we'll look at Excel briefly in terms of how these sort of functions work and formulas. So let's go ahead. There's just the three of us so far, and let me take a quick look again. Okay, nothing yet. Also, tell you now, we've been instructed to go back to what we call mid-mod advising in all of our classes. We used to do the, I don't know if any of you were here when we were doing the 2-minute meetings every week, but we are basically advising is to discuss with you where you are in the class and what you need to do to, to maximize the value you're going to get and at the same time maximize your grade. This will come to you as an email document that you will have to sign in, I think, probably Adobe. So it'll be a DocuSign kind of agreement. We'll have to see how that works. DocuSign, I don't know if any of you ever used DocuSign before, where you've signed these electronic agreements. Okay, you already know how it works.
Yep.
So that's fine. In these days of COVID, we're seeing a lot more of that. And the way things are going, it's likely to be that way for a while. California State University System just announced that they're the largest state university system in the nation. And they've just announced that they are not going to have on-campus classes in the fall. So they're concerned about a rebound of the disease with a lot of legitimacy. And we can hope to God it doesn't happen, but the virus.
So we'll be online then. We'll be on like a Zoom.
Yeah.
Then is that what we're planning a Zoom meet from now on, like an online Zoom?
You mean for the advising?
For school?
Oh, we will find out. We would like to be able to go back on campus starting next month. We will see.
It just depends on what they'll let us do.
Yeah, it depends on the state and the decisions at higher up in the organization. But we're keeping that open. If we can be on campus, we will. And then we'll deal with what happens.
Okay.
If there are further stay at home or, safer at home, whatever we're going to call it here in Colorado, if there are further instructions to engage in those, we will certainly have the option to remain on Zoom. Personally, I rather be in class. I like being able to much more clearly see the expression on people's faces when they're not getting what I'm saying. And then we can deal with it right there. You guys are real good about interrupting me and asking for explanations, and I appreciate that. But a lot of students won't do that on Zoom.
I prefer to be in the classroom personally.
It's scary to do it because you're like, oh, am I interrupting something that I shouldn't be?
Well, and for me, it's the distractions. It's I really need to focus and pay attention, and constantly having that distraction of everything around me and listening to if he needs to get up and whatnot. Just kind of, it's hard for me.
It's overwhelming.
Yeah, it is.
It's frustrating.
Hi,
and
Anna.
I'm trying to quit smoking, so I understand.
Yeah, well, I hope you're successful at that. Okay,
I want to quit.
Okay,
I
we
think
have
that
Anna
if I
on now, so Anna can speak.
Oh, hi,
up.
Anna.
Mike,
her
before
mic's
I
off.
forget, today I will have to log out around 11 because his physical therapist had to move her appointment up a little bit.
Okay, that's important. That's
yeah, it's a daily thing.
Yeah, we understand that. My wife was a physical therapist for 40 years, so we understand all that. So
yeah.
Well, actually, she still is by license a physical therapist, but she's not actively practicing.
It's something that's super important, I think.
Absolutely, yeah.
I think anything with medical, anything with like the mutual funds, everything like that's gonna stay. Like in school, education's gonna stay. Like people need to learn how to cook, though. That's for sure. Like, or find somebody that knows how to cook in your family. I can't stress it enough.
Yeah.
I want to leave Qdoba. So
I understand that. My mother was a Virginia farm girl, so she was one heck of a cook, and she taught me a lot. So
yeah, I bet. Oh, I'm jealous.
So let's go ahead and get started. I would like to start looking at linear equations first. So let me share that.
And that's
document.
Can you spell that for me?
Okay, Linear, linear equations. With a name like linear, it's obvious, or it should be clear, that we're talking about equations that if you put them on a graph, like we were doing on Monday, looking at graphing, if you graphed it out, it would be a straight line. Linear equations, the order of those is 1, meaning the highest exponent is 1, right? So the general equation for a straight line is y equals mx plus b. B and m are constants, they're numbers. Okay? So if we look at these two, m is the slope of the line. In other words, how far up does it go as it moves to, or down, as it moves from left to right. The thing about a linear equation is you can determine from 2 points what it is. You just connect them with a straight line. That straight line goes on forever in both directions. Okay? By definition, m and b being constants, they never change. The only thing that changes here are the values of x and y. Okay, so b is the value of y when x is 0. In other words, it is the y-intercept. So you can put it doesn't matter what points you are connecting, you can extend the line if it doesn't already cross the y-axis to the point that it does, and simply read that value, and that's b. Okay, so on this graph here, go ahead.
Yeah, will you just elaborate more on it? Like, I think I'm getting it. So B substitutes for would be the X?
No, B is where X is 0.
Okay.
Okay, so that is the y-intercept. It's where it crosses the y-axis, which by definition is at X equals 0.
Okay, so where it's intercepting is 0. Is what you're telling me.
The X value is 0, and so it's the Y value. So you can simply read it off the graph.
Okay.
Okay.
I'm not. I overthink this a little bit too much.
Yeah, don't overthink it. You just it's the point here where it crosses the Y-axis, whether you extend the line or whether it actually, the data you're given shows where that crossing is. Remember, a straight line can be extended in either direction as far as you want to go. You know, we say infinitely far, which is kind of a meaningless statement, but basically as far as you want to go, as you need to.
Okay.
So what is M? M is the slope of the line. Slope means how far up or down the line goes as you move from the left side of your line here to the right. So here we're looking at a line that here on the left, it's down over here on the negative side of X, and here on the right, it's at the positive side of X. By definition, this is the slope is how far up it goes for how far across it goes. And that becomes then an easily calculated number. So before we get into any further, let's actually take a look at how we do that calculation. If we come over here to a slightly different graph, M is how far up, the change in the value of Y, how far up the line goes for some distance across the plot. So it's the change in X. Another way to write this, so if we look at this, this is the change in Y. On this line, this little segment of line right here, we have, and at this end, we have, let's see, did someone else join us? No. This end, we have an X value of 1, if we assume each of these squares is 1, and a Y value of 4. So this would be the point, if we wrote this out as coordinates, the point 1, 4. Remember, X is always the first. Okay, if we go over here to the second point, the X value is 7, or 6 rather. We've come across 1, 2, 3, 4, 5, 6. And the Y value is 7. So this is the point 6, 7. X always first. Remember that. So the point that you choose your points, and you don't have, you can choose any points you can find on the graph that you want to use to do this calculation. You don't have to use the endpoints because the slope, since this is a straight line, is the same no matter where on the line you are. Okay? So the point on the far right is called point number 2. And the point on the far left is called point number 1. So another way to write the equation, the change in Y is the difference between the Y value of point 2 and the Y value of point 1 divided by the difference in the X value of point 2 minus the X value of point 1. So in this particular case, Y2 and X2 are the point up here to the right, the point 6, 7, and Y1 and X1 are the points 1, 4. Okay, the point 1, 4. So if we put that into our equation, we've got 7 minus 4, right? Y2 minus Y1 divided by 6 minus 1. Okay? Divided by 6 minus 1. So that's going to be 5. So we're dividing 4, or we're dividing, 4 by 5. So the slope in this case is 0.8 if we do the math. Slopes don't have to be integers. And in fact, most of them are not, except in math problems where we make it easy to learn the concepts. But that's how we do this. So going back to the example before, if we look at this particular plot, if we duplicate that down here, and we look at this example, we've got a slope here where point number 2 is at 1, 3, and point number 1 is at 0, 1. So we're dividing Y2, which is 3, minus Y1, which is 1. So we have 2, and we have X2 is 1, and X1 is 0. So 2 over 1. So the slope is 2. The line crosses the y-axis at 1. So B is 1. Does that make sense to everyone? We can simply read it off the graph. Okay. There are a number of ways. Graphing is one of the easiest ways, but we can look at these and know that we can calculate these various values, and then we can using that equation we can calculate any other point on the graph. We choose a value of X. Morning, Nathan.
Morning, sir. How you doing?
I'm doing fine. We've started on this. You can pick up the early part of this a little bit later when I post the recording. But we're talking about linear equations. Linear equations are equations where the highest exponent is 1. You can always tell a linear equation simply by looking at exponents. If there is no exponent greater than 1, and remember, if you don't see an exponent, it is 1. That's the assumption. So, so we want you look at that. That's a linear equation. These always are graphed as a straight line. okay? No matter what the values are. So we can go over here. We're talking about the slope of the line, which is how far up or down the line goes as you move from left to right on the plot. So and slopes can be negative. If you think about that, that means that the graph descends, goes lower as you move from left to right. This is a negative slope. If we look at the change in y and the change in x, change in y is -3, the change in x is 1. It goes through the origin, so b is 0. The y-intercept is 0. So the slope is -3. -3 over 1 is -3. So this equation is is y equals -3x plus 0. Since we don't need the 0, it's y equals -3x. And we can calculate any other point on here. Okay. Vertical lines have no slope. And there's no way to calculate them because the change in x is 0. You cannot divide by 0. So the only thing that changes is y. So by definition, a vertical slope, we cannot calculate that. And in fact, all we have to do is look at where this line crosses the x-axis. And that's the answer to the equation. In this case, x equals 1.5. Okay, there's no y involved here. So another way to look at it is you can do what we call the rise, how far up it goes, over the run, how far it goes from left to right. Okay, but remember, your second point is always the one to the right, whether it's above or below the first point, doesn't matter. Now, you can play with this by taking this link when I send it to you and see what happens. So I'm going to go ahead and actually do that. I don't know if you're going to be able to see this or not. Can you see something called the equation of a straight line on Math is Fun, or do I need to change the screen share?
Change the screen.
Got it. I thought maybe that would happen. All right, here it is. So if we scroll down here, this is the same material. If we scroll down here,
I'm still not seeing it.
nope, you're still not seeing it?
Nope.
No, I've got the wrong one anyway. So let's back up. I'm gonna go back to modules. Let's go here. We'll go here. Go here. Okay, so here is something that you can play with. If we change the slope, look what happens. And we can change it to, we can't go negative on this graph, so at least not in that direction. So let's switch it to negative. So we see that the slope, take this back to 1. And if we change the y-intercept, see what happens. The line simply moves without changing the slope. Okay. So that's what happens here. And this is an example you can look at as well. You can change these to show how just changing these values will change the slope. It's not cooperating with me, that's all right. So let's go back to what we were looking at before, I believe. We want this, yes. So you can click on there and go into Math is Fun. And I know at least Anna has done this. I don't know if anybody else has gotten onto that site. You can learn a few more things. There are other ways of looking at these things, but we won't go into that because this is the material that you need for this class. So questions about linear equations?
No, but the Math is Fun. It's just one word and it's .com.
Yeah, mathisfun.com.
And these are where you can practice these, kind of play around with it.
Yeah, you'll end up with a let's see. Yeah, you'll end up. Let's do a share here. Yeah. You'll end up with, when you land on Math is Fun, you'll end up with a screen that looks like this. So you can go to the index, you can call up any of these things, or they're all up here as well. Okay. So this is, has a lot of good general information that is fairly well explained. You can see that I've been using it because I happen to like the way they consolidate the data. Okay.
Okay.
Let's go back to, okay, so if there are no more questions about that, what I'd like to do is go to quadratic equations. Quadratic equations have the highest order is 2. In other words, there's an x squared term. There are lots higher order equations. Again, it is unlikely you will ever see them in a business setting. You'd have to be more interested in learning much more theoretical math and also, or go into one of the hard sciences before you use those. For geeks like me, they're a lot of fun, but this is, I want to introduce you so you understand what is, what's being said. The standard form that we use is ax squared plus bx plus c, where a, b, and c are constants. If we just have an x squared term, a is assumed to be 1. If we just have an x term with nothing in front of it, then b is assumed to be 1. If there is no constant at the end, it's assumed to be 0. Okay. The only thing is a can't be 0, then we don't have a quadratic equation because the x squared term is gone. And x is what we use. It can be y, z, or anything else. Okay, but this is our standard format. There are lots of ways to solve them. Here is an example. 2x squared plus 5x plus 3 is 0. So a is 2, b is 5, c is 3. Here is an example. X squared minus 3x equals 0. Remember I told you if there is no term for c, it is 0. So we have only a, which is 1, and b, which is minus 3. Don't forget the sign. And of course, that's not a quadratic equation. Now, there are lots of ways to solve it. The solutions are often called the roots of the equation. There are some complex ways of doing it, or we can simply create a table, pick a value of x, calculate y. Pick another value of x, calculate y. The easiest one to calculate is x equals 0, because the value of y is whatever the value of c in the standard form is. Where this So you plot this out and you'll find that it forms what we call a parabola. This is a regular shape, one of the regular shapes, and it is one application that you would have for these would be if you were in a military artillery unit, because this is the shape of the trajectory of an artillery shell after it's fired out of the cannon. So this actually tells us where, this is how they calculate what elevation to hold the barrel of the cannon. So where this curve crosses the x-axis are the roots. Okay. So in this particular case, this looks like whatever this equation is, it looks like one root is -2 and the other root is +7. Now, how can we have two roots? Well, it's an x squared term. And remember what I told you was that when you square x, you can have positive and negative values. So any quadratic equation will have two solutions. They don't have to be positive and negative. They might both be positive or both negative, but you have two solutions to that equation. Okay. All right, questions?
That would be, I don't have a question, but can you repeat that? It's two solutions. So one's a negative, one's a positive?
Doesn't have to be negative and positive. Both can be negative, both can be positive. It depends on where this curve lies on your coordinates. Now,
Okay, so two solutions regardless.
Go ahead.
Sorry. No, you're good. I was just repeating you.
Yeah. If it does not cross the x-axis, that means the solution, it doesn't have a solution that's real. Remember, we haven't talked about this, but there are a class of numbers called imaginary numbers. And they're imaginary because they are the square roots of negative numbers. You cannot have a square root of a negative number because you can't multiply anything by itself and get a negative number. So the square root of 4 is 2. The square root of -4 can't be 2 because 2 times 2 is 2. It can't be -2 because -2 times -2 is 4 plus 4. So where we have a negative square root involved in the solution, it is not a real solution. So this is of mathematical interest more than anything else because in the real world, you don't have such things. At least not especially not in the world of business. Computers used to freak out when you had something like that, but I think they've solved that. But you can have these things. The square root of a minus number has the number I involved in it, and that the number I is the square root of -1, because in the case of the square root of -4, we can make that the square root of -1 times the square root of 4 because we can factor -1 out of 4. And then it becomes the square root of 4 times the square root of -1. The square root of 4 is plus or minus 2. So we call the square root of -1 I to make it an imaginary number and end up with plus and minus 2I. Those are meaningless in business. And I'm giving you that because you may run into it hither, thither, and yon in your life. And you know that if you solve a problem in business and you come out with the square root of a negative number, you know you did something wrong. Either the data's wrong or you made a mistake in the calculation somewhere. So there's something to consider. Okay. Questions? I'll be posting this. You can take a look at the rest of it if you like. Um,
Does the,
or not. As I said, I doubt seriously that you will have any use for quadratic equations in your business life. However, knowing what they are is important. And
are they in
fact,
the Math is Fun?
sorry?
Are some of those problems in Math is Fun or?
Yeah, this is all in Math is Fun.
Okay.
So, questions?
Not so far.
All right. Okay, we still don't have Angela.
I'll be right back. May,
You're breaking up, Anna.
yeah, that's what I'm saying. I'll be right back. No, log out and come back on
Okay.
because it's having issues.
Yeah, I can hear that. Or maybe I should say I can't hear that.
You sound just like me on
Oh,
Can you hear me now?
Yep.
Y'all are funny in the morning, you know that?
That's
You
okay.
all are so sleepy.
Yep.
Y'all need coffee.
Yeah, we also need humor.
I got you.
Yep. Well, there's a
Humor
reason.
helps a
Smiles
lot.
are contagious. Smiles are contagious.
Yeah, there's a reason that we say laughter is good medicine.
It is. I love it.
Okay.
I'm just kind of laughing at you guys because you guys crack me up. You're all so tired, and I'm like, I got something in my eyeball right now. I'm trying to like manically get it out.
Yeah, understood. So
Probably my hair.
I've had
Let's-
plenty of coffee, just lots going on around me.
yeah, coffee is a necessity. So
Yep.
what I would like to do next is, let's find it. Is look at the worksheet for this week, because there are some issues, and we'll go back and take a look at the assignment as well. But if you look at this worksheet right at the beginning, we have these two monstrosity equations here. They look complicated. But let's go and look at the discussion part of the assignment, the part that explains what's going on, and look at these equations, because you'll see them there. So we'll go back to new share.
And then this is our worksheet.
Yeah, it is. You download
This is for
that.
the linear.
Pardon?
Or this is, which one is this?
This is the assignment worksheet, not
The
the in
assignment.
class, but the assignment worksheet. No, what's going on? All right, let's go here. Everyone see this now? Okay. So let's look at the assignment and take a look at this material. The assignment is about graphs and equations for loans. You know, this is something that is useful in most businesses. So you'll have an opportunity here. So looking at loans, we have a number of choices of potential equations. One is to find the effective rate of a loan. Now, there's a difference between the effective rate and the stated rate. The effective rate is what you pay depending on the payments. And so what we have here is this formula means let's see if I can zoom in on this some. Okay, good. If I inflate this, what this formula, these values here, this formula for the effective rate is, this is 1 plus the actual stated rate. So let's say you're taking out a 30-year loan, and you're making at 5%. So this, and you make monthly payments. So you're making monthly payments. So the rate in any one year, or the amount of interest in any one year, is 1, meaning the total, plus the rate, 0.05, divided by the number of payments, 12. So then, if we look at this, and then multiply this for one, the effective rate for a year, this n would be 12. But if we were looking at any further, and then -1, because of course what we have is we're going to get a percentage here. So r over n, 1 plus r over n to the n. So when you were solving this, the first thing you do is calculate r over n and then add it to 1. So if you've got 0.05 divided by 12 plus 1, that's what's going to be in the parenthesis, and then raise that to the nth power. How do you do that? Well, on my computer, the scientific calculator here is, if you put in a number and you want to know, say, what the 10th, what this number raised to the 10th power is, what you do is, let's clear that. Let's just say 2 to the 10th. So we type in x, press x to the y, and then type in 10, and then equals. So it's 1,024. But what is 2 to the -10th? So let's put in 2, x to the y. If you're going to use a negative number, you have to use parenthesis, because the calculator, being a piece of stupid electronics, will simply then, oh, you really mean 2 minus 10. So you have to put the negative exponent in parenthesis, and then equals, and then we get this number. Make sense?
Can you show us?
Pardon?
Could you show us?
I just did.
Oh, we didn't see it. I was wondering.
Eek. All right, I keep forgetting that this thing, even though
I was wondering why you were typing and I wasn't seeing nothing.
Okay,
I'm like sitting here, I don't know.
Now do you see the calculator?
No, we do not see a calculator.
I just
Maybe-
told it to share.
Maybe if you tap, there we go. Whew, there we go. Thank you.
Do that now.
Like, I know what you're typing, but I didn't
Sorry
know if
about
you were
that.
making
You
a
need
note.
to remind me, because I forget that I can't just bring this stuff out of the foreground or out of the background.
Okay, sorry about that.
So raising a number like to a power that is anything other than, on this calculator anyway, the second or third, we have to use the x to the y function. So x is what we enter. X to the y, oops. Let's clear that. So x is what we enter. That I'm going to make it 2 to the 10th. Then click x to the y, type in 10, and we get 1,024. If we want to know what 2 to the -10 is, we again type in our 2, click x to the y, and then we have to use parentheses to put in the -10. Otherwise, the calculator just assumes that you made a mistake and you're really just subtracting 10 from 2. So if you put the negative has to be in parentheses. Okay, and then we get this result. Okay? Is that clear to everyone?
Yeah.
All right. So let's go back to here. So now we're back in the assignment. So payment for an amortized loan. Amortizing is just payment over time. Okay. And there are lots of ways of doing that. This R means payment. And this P is the principal, the amount you start with. So if you have a $50,000 loan, P is principal. Okay. So then we have, so that is the payment. There's lots of ways of showing this. We'll go back to the worksheet in a minute. And then this should not be a 1, it should be an I, meaning the interest rate. Okay, so that's an error here on the page. To the minus N. Okay, and again, what you do is you add the rate. If it's a 5%, this would be 1.05. So you'd put that in your calculator, do X to the Y, parenthesis, minus whatever the number of payments is going to be. Okay. Does that make sense? Calculate that first, and then do the rest of the problem. So remaining balance, B, is the payment, R, that came from up here. The payment times this complicated looking fraction, but if we take it apart, we've got parentheses to solve. The first parenthesis to solve is N minus X, which is the number of payments that have been made. You start off with a number of payments. If it's a 5-year loan, you've got 60 payments, monthly payments. So 60 minus, and if you want to know what the balance is after the first 2 years, you've made 24 payments. So this would be 60 minus 24. That's a positive number, so this is still a negative number. Now, can this ever be a negative number? No, because the maximum value of X is N. Once you've made N payments, you're paid off. So this is always going to be a negative number that we're raising this to. So again, I is the interest rate, and then we divide it by the interest rate and multiply it by the payment. That gives us the balance. Simple interest earned amount. I don't know why they use L here. Nobody I've ever seen uses L for this, but it's the principal times the rate times the time. Okay, rate is going to be per month and then X number of months. That's the earned amount of simple interest. This assumes that the rate is per year. Okay, simple interest is not compounded. Most of the times these days, interest is compounded, so a little bit more complicated, which is down here in this formula. So here A is the same as L. I think they use this because they want to differentiate the difference between simple interest and compound. So the principal times, again, 1 over R to the N, which is the number of payments, and N times T, which is the number of years. Okay. So these other formulas are basically geometry and other sorts of things. You know, we can find the area of a circle. Area of a rectangle is the length times the width. The area of the triangle is 1/2 the height times the length of the base, which is the longest single side. Okay. So we've already seen volume, height, weight times distance or times depth. If we are trying to figure out how far we've driven without using an odometer, we know the distance. If we know our average speed, which is going to be miles per hour, times time, the number of hours, then we can figure out the distance. And we can rearrange these formulas if you remember, okay? So they once again go into an explanation of PEMDAS, and then they talk about graphs. Okay, we'll see those as well. The same material that I gave you on Monday. Here are some extra references you can look at. You may want to look at a couple of them and see if they're very useful. I found this to be a bit cumbersome. The Business Math for Dummies cheat sheet. I actually hate the phrase for dummies because you guys are not dummies, but that's my bias. So let's take a look now at the actual worksheet which you download. Okay, so here we see a version of that first formula we discussed, the monthly payment. A here means the payment. Okay, so they've changed some of the formula. This is basically the same thing we had before. P is the principal, in this case a $50,000 loan. Okay. R is the rate. Remember, always convert percentages to decimals by dividing by 100. So this would be 0.05 times 1 plus 0.05 times N. So we're monthly payments for 3 years. So that's 36. So you first calculate 1 plus R and then raise that to the 36th power and multiply it again by the rate, 0.05. And then we divide that by that same number minus 1. You will find that this number turns out to be, 4 or 5, between 5 and 6. 0.05 times 1.05 to the 36th is between 5 and 6. Or 1 plus 1.05 to the 36th. So you can calculate this out and get a payment. So think about how you solve this. PEMDAS is the rule. First thing we do is fill in the numbers here in the parentheses with what we know. Remember that P is the principal, R is the rate. Now is the interest rate. Using that problem, what we want to do is figure out the remaining balance on the loan after 1 year, when there are 2 years remaining. Okay. Again, we have the payment, okay, and 5%. So again, we do that, okay. N here, remember, is 36 because it's a 3-year loan. X is the number of payments we've made at the end of the first year, which is going to be 12. So we have a different exponent. So we multiply this out. Remember, R is the payment that we calculate in problem 1, which they call A here. And then B is the balance remaining that we calculate. So again, first solve this parenthesis, the exponent. I know we're supposed to solve exponents first, but an exponent that contains parenthesis is the first thing you solve. And then you simplify this parenthesis by raising it to whatever you calculate here. Do the calculations, do this next. and divide by 0.05. Okay. So we have to, we simplify the material on the top of the fraction first. You know, it's sort of like assuming that the top of the fraction, all of this is in its own parenthesis. We have to solve and get this number at the top first. And then we solve for the balance. I went through this a couple of times and figured out this. So it does work, and it does even make sense. Okay. So that's what you'll be working on in the assignment. So here we're going to make a line graph. What I want you to do is you can actually, using Math is Fun, you can download some graph paper if you want to and print it, or you can make up your own because you don't have to include that. Or you can go into Word or Excel and try to plot it. Okay, so what we're looking here is how you create the graph. This is a description. So think about how you do it. You may want to do it by hand so you can go back and recreate how you did this, how you solved this problem. Okay.
I'm having some computer problems over here.
Oh, yeah?
Yeah, it's so slow.
It might be because it needs to be updated. That's what mine did.
I think you're right, Anna. I think I need to shut mine, restart it.
Not your computer, just Zoom.
To Zoom. Yeah, I've been having problems with Zoom because I'm doing Zoom for my career.
Yeah.
Too.
Yeah.
So
let me warn you, Zoom will slow your computer down.
It will. Yeah.
I had a devil of a time on Monday. I don't know if you noticed, but things were going very slowly on my end because not only did I have Zoom running, but I had it recording, and that really slowed things down. I also had a number of Word documents up, and so it was slowing everything down. So, so again, problem 5 is the same thing. You're going to look at explaining how you create a graph. So I would graph it out and then just write out how you did it. Okay. So let's see. Oh yeah, here we have a simple interest. So remember we discussed principal rate, which is going to be X percent per year and 10 years, right? Whatever they tell you.
I'm sorry, I keep hearing knocking. I will be right back.
Okay. So go ahead and do that. So right now we're going to take a break, take about 10 minutes, and we'll come back at 10:15, okay, or so. Any problem with that for anyone?
Nope, sounds good. See you in 10
Okay.
minutes.
All right, I'm going to pause the recording. So I am
also,
recording now.
Okay.
Okay.
I
So
made
during
a
the break,
little chat with
Nathan asked to explain how we set up problem 1. So what I'm going to do here is switch to a new screen. If I can find there we go. Okay. So I just copied this out. Unfortunately, I can't just substitute it because this is actually an image. So what I'm going to do is remind you that the P is the principal. Which is $50,000. Okay. N I have the same problem Anna has. It doesn't seem to want to remember that I like sometimes to have small numbers. N is the number of payments.
Harley, you're on mute.
So,
Like, thank God it's not me.
so these
Mike.
are monthly for 3 years or 36 payments. Okay. A is the amount of each payment that you're going to make. And R equals the interest rate or 5%, which is equal to 0.05 as a decimal. We can't use percents in these equations. Percents are just a nice way to express a decimal number as a whole number or as a larger number. So that's 5%. So what we do is now the phrase 1 plus R is equal to 1 plus 0.05 or equal to 1.005, okay? So those are the values that you substitute in. So the first thing you ever do, you look at this parenthesis, remember parentheses are first, PEMDAS tells us that. So we go ahead and add those numbers. And then we've filled out the parenthesis. The next thing we do is the exponent. So use your calculator. So it's going to be 1.05 to the 36th. Okay, so use your calculator for that. Okay, and then multiply that by 0.05 again, the rate. So that gives you this numerator. The denominator is what we just calculated for 1 plus R to the 36th, subtract 1 from it. That's what the denominator is. Divide those two, and then multiply by the principal of $50,000. And that'll give you the monthly payment. Okay. 3-year loans are short, so the monthly payment will be high. Don't be surprised at the number you get. Okay. Make sense?
Yes, sir.
I'm kind of lost.
Okay, where
I'm
did
not
I
gonna
lose
lie.
it, Holly?
I'm not gonna lie.
So are we doing, an in-class activity today or no?
We are.
Okay.
I was going to start it right away, but we'll start it as soon as people are happy with how we do these substitutions. Now,
Okay.
if we go back to the worksheet, the next problem down looks confusing, but remember, this R is really what you calculated up here as A. This is a problem I'm having with the notation. It's confusing. Just remember that R in number 2 is A in number 1.
What about B?
Answer
Okay.
to number 1 you calculate goes here.
This is our in class, right?
No,
No, this is
think
the
this is
assignment.
your assignment.
This is the assignment.
Yep, this
Okay,
is the
no wonder
assignment.
why I'm confused.
Yeah.
Michael, what about B?
Go ahead, Nathan.
What's B?
What is what?
What's B? Because you say R equal A, right? But what about
Yeah.
B?
B is the answer you're looking for, the remaining balance.
Oh,
Okay. So this is what you're going to calculate. And here, what we have is, remember, you're looking for the remaining balance after 1 year of payment. So that's what with 2 years remaining means. You've made the payments for a year, and you have that, so you've made 12 payments. So in this particular case, N is the same number that we started with up in problem 1, 36. And we've made 12 payments. So we calculate the difference between 36 and 12 here. And remember that when we do the x to the y function on a calculator, we have to put the negative number, this will be a negative number, we have to put the negative number into parentheses. Otherwise, you'll get a meaningless result, all right? So remember, you're explaining how you solve the problem. You have to solve this one, number 1, to get to number 2. Okay?
Hi, Cody.
Oh,
Okay.
hi, Cody.
Morning, everybody.
Cody,
Hey, Cody.
you're my hero today.
Issues. Yay.
How's everybody doing?
good,
Doing
man.
okay. I
That's
kind of
good.
need your help.
What kind of issues are you having, then, Miss?
Well, I've been doing a lot of research and stuff on here because of my job in school, but I think I need to do a computer scan.
So you'd have to go into computer security to do a quick scan.
Or you could go down to the
Properties of the network.
Harley, do you have a virus scanner on your computer, or are you using Windows Defender?
Let me check.
If you go down to your bottom right, where the battery icon and the Wi-Fi icon and stuff are,
Yeah.
clock, that little arrow down there, click that, and it will open the little window.
Yep. The color, it's the colored one, right? The yellow, blue, green, and red. Or
Yeah.
is
There
it?
should be a shield icon.
Yep. Yep, with a green, it has a green check. It says,
Yep.
I guess it says no action needed.
You could double click that guy to open it.
Okay. Windows
And then
security.
you could
There it is.
press the virus and threat protection.
Okay. It says no action needed for all of them.
Does it give you an option to quick scan?
It's under
No,
correct.
I must have already done that because, or yesterday, I must have already done that because it's not giving me an option. Is it on one of the side icons?
So there's also a little bar. It's should be at the top, but
It just says everything, no actions needed. I don't understand. Why is it being so slow? Is it because I'm running a lot, or could be my Wi-Fi, huh?
It might be, but we could, since you're in class, do you want to talk after you get out of class, or do you have to work today?
Nope. Well, I do have to work. I got a job, a better job, but I have some time today that I can meet up with you.
Okay.
So just Zoom with you, or?
Yeah, we could just Zoom together, and then I'll have you share your screen, and I could remote in.
Okay.
using Zoom.
All
And
right.
get you straightened out and see
Awesome.
if there's anything that I could help you with for that
Awesome.
issue.
Thank you. I'll hit you up right after class then.
Sounds good.
All right. Thank you, Cody. Have a good day.
Yep. Anybody else having any issues or anything?
No.
Just network issues that can't be fixed at the moment.
Yeah.
Considering
Everybody's
I
having the
had
network
to look
issues.
at my properties and it was saying that it was in the public for my network instead of private. So I had to change that, and then Zoom was acting slow, so it had to update. Yeah.
Gotcha.
The
Yeah,
normal
everybody.
stuff of computers.
Yeah. Yeah, like, especially right now since everybody's on the internet, it's
Oh yeah.
share it, or if there's a lot of people on your internet, then it will go a little slower than usual because everybody's on it. So
I think especially in the mornings, because there's pretty much everybody's doing something online in the mornings.
right.
My mom has 3 devices in front of her. 3.
That's a lot.
Uh-huh.
If you guys have any issues, feel free to either shoot me an email, give me a call, or shoot me a Facebook message. Either way, those, and then I will hop on Zoom or email you guys back and let you know. But I'll try to join you class again next week. Make sure everybody's good to go for your week 4. And hopefully we'll be back on campus next mod, but who knows if that's going to happen or not. So, but you guys get back to your class and enjoy this math.
Thank you, Cody.
Yep.
Thanks, Cody.
Yep. And Harley, I'll talk to you in a little bit.
Sounds good. Thank you, bud.
Yep.
Thanks, Cody.
Guys, have a good day.
You too.
Okay. So now what I have is we have an in-class activity. Let's bring that up. No, that isn't going to work.
I need to learn when to shut up. I feel like I was talking over him.
All right. Just have to find the right screen here that we're going to do a new share.
I was trying to say, Anna, it's okay. We all do it. I'm really bad at it because the Zoom, you never know with body language who's going to say something if they're not completely showing, you know?
Yeah. Well,
All right.
it's hard for my computer to be at my face all the time because I'm doing other things at the same time.
Right.
Can everybody see this?
Let me be get bigger.
Week
We
3.
got
We
week
can
3
see the week
in-class
3 in
activity.
class.
So go ahead and in your shell, call up the worksheet. And
That was for the in class.
let's see.
Where
I
am
see
I?
class activity week 3. I click on it, submit assignment, and nothing else.
Are you in modules?
Yes.
We're in 2 different shells, remember?
Oh,
And
yeah,
I brought this
forgot.
up. This is what it looks like. Let's go back to here. This is in modules. So you just click on the worksheet and it'll pop up. The usual, work together. I think you'll find most of this is pretty straightforward based on what we've discussed Monday and today. So go ahead and work together on this.
Mine doesn't. Mine does not have a download.
Click
Nope, ours is just submit.
click on the word worksheet and it should download it.
I don't even have that, but let me go into a different, thing, see if I can find it.
Go into week 3 of Canvas and then look for the week 3 in-class activity worksheet.
I see in-class activity week 3, but when I click on it, it's just stating submit assignment and nothing else.
This is supposed
That's
to be.
what mine's doing. No submission.
All
It's
right.
not posted.
Refresh Canvas
Okay.
and you should be able to see it now.
Remember, Nathan and I are in a different shell.
All right. I'm not even seeing mine.
Right, let me go back and call up that shell and fix it. Hold on.
I don't have mine either. But
I'm looking. I don't.
yeah.
I went ahead and totally went out of it and went back in. Yeah, it's not. Well, wait, hold on.
Will be provided in class. It may include submission.
Yeah, mine's not showing the link on mine either.
Yeah.
So I'm going to go back out of the dashboard.
Me too.
Lawn care people are here. Yay!
What?
The lawn care people.
Oh,
Which means my allergies are gonna kick in here in a moment.
I love the smell of fresh cut grass.
I do too, but it kills me. I like it when it rains. That also kills me.
Well,
Yeah, I'm not getting. I don't
We've
have
had-
one, Mike.
Just a
We've had
second.
rain
Okay.
and we've had
You guys received the check from the government?
Yep.
The stimulus.
Yeah.
And I
Yes.
got the one from the school too.
Somehow,
Hello.
some way, I don't understand why, but child support sent money back to me, and I feel like it's a test.
Hey, accept it.
either that.
I did accept it, but I'm not gonna spend it just in case, because who
Right.
knows? Like, I want to give that to. I want to catch up on all my bills, get out of debt, and that way I can be a great, asset
You know,
manager.
put it into a savings account, and then when they ask you for the money, you can send it to them.
That's true.
Since they sent, I'm guessing, over what you owed to them for this month.
No,
No?
I owe way a lot. It's crazy.
Well, if they
Think
are,
about Robinhood. That's pretty much my life. The rich likes to steal from the poor because you have to work really hard. So I'm gonna be rich anyways, girl. I'm not worried. They can try. This girl ain't going anywhere.
Okay, Nathan and Anna, you should have it now.
Poor Mike. He's just working up
my
a
mom
storm.
decided to hand me breakfast.
It seems
I
like
had
a
cereal.
whole bunch of things that I put into your shell on Sunday didn't get in.
There it is.
So you should be able to have it now. Does everyone have it?
I still don't have it, but I'm still gonna look in another place here. Give me a
Let you
sec.
know in just a minute. My computer, of course, because I said it was doing fine, is slowing down.
Of course.
Karma.
Poor girl. She don't need that kind of karma. All right, I'm not
At least
getting
I
one,
have
but
in-house. At least we have internet now. I went ahead and signed up with Xfinity, so I'm not going through my phone. That was gonna be really frustrating.
yeah, I bet.
Xfinity actually has really good internet speed. I'd suggest, though, you go with the highest bandwidth without the 2-year contract.
I went with the $10 a month cheapy thing.
Take a look again. You should both have it. All of you should have it.
What did it say, Kim?
Okay, I'm going to take myself off of video. I'm still here, but I really do not want to be on recording eating.
Okay.
I can't see mine.
As Mike tries to hide his laugh.
Michael?
I'm
Oh,
sitting here
Mike,
thinking,
he's not gonna laugh or smile when I tell him I'm still not getting it.
I wasn't either, but I closed out the shell and went back in
Okay.
refresh to see
You should
that.
be
So
able to
week three
simply
in class.
refresh the shell using the little, the little circular arrow in the upper left. You
Yeah.
should be able to
It's in
refresh
there
it and
now.
get it.
I got it.
Okay?
Why does it hate me? Okay, let's try it again. Why do you hate me?
Okay. If it doesn't load, you might want to exit out of Canvas and then relog into it.
It worked for me. I got mine up and going.
I'm about to do
I'm
it.
opening it now.
I'm about to do it.
Let me know if you still have a problem, Harley.
Oh, I'm still having a problem. It hates me. It's all right. It's just being super slow. Okay, now it says it's done thinking, but it's still not here. Because it's just blank. It says this activity will be related to the work for the week.
There should be a
providing-
document right below it that says
Worksheet.
free in-class activity worksheet.
Let me exit. Let me exit out. I'm gonna go back into it again. Let's see if it did it. Love my technology. It hates me.
Okay. Technology sometimes hits.
That's your mind.
Harry walks over and boom, it's like, really? You couldn't have done this for me 5
Instead, you
seconds
see
ago?
yours?
I've got mine. I pulled it up, but I closed out the shell and just went back in fresh.
That's what I'm gonna do. That's what I'm gonna do. I'm doing it right now, so it's just being slower than molasses. Somebody must be playing their poker out in the living room.
That's what I just did, but I won't be able to.
Oh my God, why are you so slow? Okay, I got this.
Hey, Nathan, do you have it?
No, sir.
How much files have you saved on your computer?
Wow, mine's not downloading or coming up with a link.
Me too.
We're hated on.
Okay, are you guys in the worksheet or are you guys in the submit?
We're in the in-class activity week 3.
Look
I've
for
gone to
in-class
modules. I've gone to
activity week
grades.
3 worksheet.
Can I share my screen with them really quick, Mike?
Yeah, just a second. Let me stop share and
Enable.
All right, we'll try it again.
okay. You should be able to now, Anna.
So there's this one, which has it's in week 3 in-class activity worksheet. And then when you go over here, down, there's the in-class activity week 3. And then right below it, right here, is week
It's
3
its own
in-class activity.
tab.
Yep.
Okay, that makes a lot more sense to me. Give me 1 second. I'm gonna do some magic here. My God, Zoom is in my way though. Okay. Come on now. Being slower.
It's okay. It's one of those weeks of.
Well, my computer is almost dead, but I plugged it in, but now it's even being slower.
I see
Love
mine.
it. Love it.
Do you have
Okay.
it, Nathan?
I got the worksheet. I'm in there.
Okay. You have you're on the in-class activity worksheet.
I'm downloading it. Yep.
Great.
Downloading the worksheet.
Super.
Nathan, if you go back into, so if you hit modules,
Uh-huh.
so you should be able to get up to the list.
Yeah, I already got mine.
Oh,
You got
you're
your-
good?
Yeah, I got mine.
You got it?
Yeah.
He's
Okay, good.
fast.
So I'm going to mute because there's noise here. Let you guys work on this. If you need help, just call out and I will, and give me a few seconds to get unmuted and I'll be happy to help.
Okay.
Anna, can you share your screen so we can just probably give ideas?
Yeah, Mike has to unshare his screen though. Mike.
Where'd you go? Oh my Lord, why are you? Oh my,
He's like, I'm out of here.
oh my, yeah, he's like, I need a break right now. And my computer will not stop being slow.
Mike.
There it is.
Catch him while he's there. No.
Apparently I need to share my screen. Mike. Michael.
Make.
He's ignoring us.
He's busy. He's on his break.
Okay, well,
Hold on. So,
okay.
like, so that first one, I was just looking at it. Oh, let me switch back over to my other screen. So that first question is the graph. I mean, that sounds kind of, my computer's doing stupid stuff too, guys.
Oh man, you guys, I might have to restart my
I
computer.
know. It's like, oh, you need me to do something now? Let me just slow down.
I think it's
But
because we're all trying to do it.
right. So it says Tammy recorded the amount of time she spent on 6 activities over a 24-hour period and drew a bar graph as follows. Approximately how many more hours did she spend sleeping than watching TV?
So you would basically take where your TV, the blue,
Mm-hmm.
and you would take that line. Are you saying because it's like a point?
Yeah, so it's just below 5.
So it would be what the sleep
To the
is.
just above 8. So
I would say 3.5.
3.5. Yeah, that's what I was going to say. So A would be the answer there.
That's what I would say. Ah, my computer.
I know. I was going to say if I could just make my computer go where I want it to. Okay, so A. And then
The histogram, there we go, shows the birth weight of 100 newborn babies. How many babies weighed 8 pounds or more?
okay, so we've got the weight is on the bottom.
Mhm.
So 8 is between the blue and the green.
So
One.
How many babies weighed 8 pounds or more? So
Well,
those
there's
are
22,
small.
8 through 9. And then you have to
or
add,
more. So the babies that weighed 8 pounds or more. So you're taking all the ones to 12, from 8 to 12, and you're adding all that. Correct?
Yeah. And so there's 8 little squares. So that would be 8. Am I correct?
Where?
Oh,
The
so
weight
okay,
is on the bottom on the
yeah,
x-axis.
okay, the weight is on the bottom.
Right.
And
And
so
the number of babies is on the y-axis, on the
right.
left, or it can be on the right, but in this case it's on the left. And it's just wants you to take the 8 pounds, which I think that's 20. Oh, 1, 2.
Right.
I think that's 23, right?
Well, yeah, you've got to figure out how many excuse me, how many so the lines are in 5 increments essentially. So
Yes. I don't know if that's, my eyes are so bad when it comes to
I
graphs.
know it's so tiny, I can't hardly.
I think this, the 9 is 16. So you would take 23 plus 16. I don't know, actually, how much more you would take that from the, now I'm lost. Now I thought about it too hard.
unless they are, so this histogram shows the birth weight of 100 new babies. Is how many babies weighed 8 pounds or more. And what I
22,
got was not one of the answers.
Right? Yeah, me either. So,
23. Well, they're saying what's the largest amount that was 8 pounds. So, right?
well, no, they're wanting to know. Okay, so first of all, I think where we're getting tripped up is there was out of 100 babies born. So our list on our y-axis, there's not 100 on there.
Yeah.
I'm saying.
Mm-hmm.
Well,
So, like,
it would equal 100 for the how many in each pound.
right. So we need to figure out basically the difference between the 8-pound babies. Oh, you know what? We're going in the wrong direct. Like,
Going in the wrong direction, huh?
yeah,
I
totally
keep
in the wrong
overthinking
direction
this a
because
lot. I
because
think it's 23.
What was number one?
Wait,
number
what?
one was A.
Yeah. Sorry.
So 8-pound babies.
It's 23 of them.
That would be B, not A.
No,
Well,
he was asking what
on
what
number one.
question, yeah, question 1. But yeah, B23 because it says 8 pounds or more. How many babies weighed 8 pounds or more? I mean, I don't know. That's this
8
one trips me
pounds
out. Where's
or
Mike?
more. Read the question. 8 pounds or more. That's anybody that weighs more than 8 pounds. You're not limited to the 8 to 9 interval.
I'd say it's D.
Yeah, 23.
I would say it's 23 because there's no other babies over that.
What do you mean? There's
Well, there are because there's
10-pound babies, 10-pound babies, 11-pound babies.
But look at the number of how many. I don't know. I don't know how I got it. But when I look at this graph, I look at the largest number of 8 pounds or more, and that's how I got it. Y'all are confused, huh? I see your faces.
we're overthinking it.
I think it's 23.
I think it's 45.
Why?
Why do you think it's 45?
Because with the 8-pound babies, and then I added the 9-pound for how many is in there, and then the 10, and then the 11.
And the 12 too? Is it?
There's no 12-pound.
Oh, there is no 12 pound. You're right. Thank God, man. That's a big baby. God dang it. Okay.
11-pound is too much.
Is that the 3 more? That's
I say it's 22 if you look at it and actually just count. Like, take the 9 through 12 lines and figure out how much of each one of those it's gonna. And the lines are so tiny. It's either going to be 22 or 23. But I think I counted 22.
Well, the 8-pound babies are 22 for in there. For how many is in 8 pounds. However, I'm also adding the rest of them. So either I'm doing something wrong or not explaining this very well. You're still muted.
Okay, you're overthinking it.
I am.
Remember, everything is simple. 8 pounds or more. An 11-pound baby weighs more than 8 pounds.
Right.
So that's included. A 10.5-pound baby weighs more than 8 pounds. Anything over 8 pounds. So
So you're adding all that.
That's right.
So Anna, you are right.
Okay.
So it is D. No, yeah.
Yeah.
Because I get confused with the lines being so small, but yes, it is. Dang it, why aren't you letting me edit? Okay.
On the baby survey where she asked all the children in the school to name their favorite pets. The results are shown in the pie chart.
There are 800 children in the school. And that their favorite pet was a fish.
So essentially, you want to figure out.
It's my name.
Yeah, it is your name.
So
If there were 800 children in a school, how many said their favorite pet was a fish? So it's very simple, guys. It's the fish.
right, it's the one without a percent. So you just
Yeah.
have to figure out the percent. Which
Well, if you're looking at the 7, or the 6, I would say it's 3 or 4.
or you could just add together all the percentages and it'll tell you the answer.
For the percentage.
For the percentage. So the way
However,
that
we
I
don't
automatically
have
look
any.
at it, I would add 28 to 36 to 8 to 11 to 6 to 7.
But
You
it
come up
says
with
if there
90.
but it says if there were 800 children in the school, how many said their favorite pet was a fish?
Yeah, but
That's what they
first you want to find that percent. So we're looking at a graph that's telling you the percent. So if you add all those percentages, you come up with 96. So the fish would be 4%. And then you figure out what is 4% of 800.
So 800 times, what is it? 0.
0.0.
Hey. Oh, there's a percentage on here. 0.4 or 0.04. 32, D. It's the one I got. Everybody agree with that?
Tell me how you did that again.
So on the calculator, there's actually a percentage sign on
Right.
the standard. I just typed in 4 and then hit the percent, but I did 800 times 4% and got 32. Because a percentage is a decimal.
Mm-hmm.
If you convert it, it'd be 0.04.
Right.
So multiplication for percentages, it makes it go down. Because it's not a, what's it called? We just went over all these names for them. It's not a whole number. But there's another name for it, and I can't remember it.
Just whole number is good to use. You know?
Yeah, but there is, for percentages and decimal points, they're not whole numbers.
Right.
When you use them, it makes it go down in numbers.
Negative. No. It's a negative. No, I'm just kidding. Are you guys on 4?
Yeah.
Yep. Are you ready to move down to 4 though, Harley?
Yeah, I'm ready. I just wondering if you guys are ready. The line graph shows how the population of parrots on an island declined over the 10-year period. From 2001 to 2010, measurements were taken at the beginning of each year. What was the total decline in the parrot population over the time?
Okay, so you've got your times on the the timeline on the bottom,
Yep.
and the population
Is on Y.
is on Y. So the highest it was at 60.
The lowest I want to say is 12 or 13.
I think it's
I think
13.
it's 12.
12 maybe? I think you might be right.
I swear I'm going to end up straining my eyes with this. Why do the graphs have to be?
Oh, let me get a paper. I have to use a paper. I have to use a piece of computer paper.
I just made it bigger.
That's,
Yep,
I think
12.
it's 12.
It looks like 12 to me.
12, yeah.
Naturally. There we go. All right. And then you said it was 60 for it.
60 was the highest.
Oh, shoot, where is my lid?
And 12 is the lowest.
So it's a difference of 48.
My goodness, I can't. Oh. There it is. Oh, yeah.
So we're off a little bit. At least I was off by a little bit because out of the 4 answers, 48's not one of them.
Yeah, no.
46. Only 46 and 42.
Yeah.
No, wrong one. There we go. And it was a 9-year time period. I'm missing something. What is the equation to do this? I know how to get information off a graph. It's plugging it into certain equations I have an issue with.
I think I'm definitely overthinking this because my head's starting to pop.
I'm going to say it's 32. Because it also went up in 2007.
Let me go back up there.
So the decline didn't just
Just then
go
went back up
straight
and
down,
then, yeah.
back up.
A
And the-
parabola. A parabola. I can't even say that word. You guys, I might restart my computer because it is being really slow.
Oh, it's not 12, it's 14
Oh my God, come on.
for the lowest number. Because it's going up by 2s.
Oh, I see what you mean.
Yeah.
Oh my goodness. Okay, I just caught that too.
It's like,
So the lowest is at 12.
right.
It's would be what?
For what?
15? Would it be 15?
No, it goes up by 2s. So 2, 4, 6, 8. And then whichever one comes next. So
Wait, you lost me.
at 36.
Oh, I see. Are you talking about 2007?
Yep.
Okay, I'm sorry. I got my paper on my computer trying to line it up.
Yeah.
What you guys doing?
You can always make it bigger too.
It really doesn't even matter because it's the lines that are so dim.
Yeah, you
That
can
makes
make
sense.
it bigger. The lines become thicker and easier to read.
Yeah, but then I might goober it up. I don't want to do that.
What you guys doing?
Stretching. Just stretching over here.
Because I'm outside.
Nathan, are you trying to say something?
Yeah, what number you guys doing?
What number?
I'm down on number 8. I kind of skipped ahead because I've got to get going so that his therapist, they can get everything for her. She'll be here. She's coming right at noon today. So
Yeah. The heck is happening here?
you need to get up again. Give it just a minute. I have one more thing to do on here and then I'll come help you, okay?
Number 5.
Yep.
Did you get B?
Line of
Scatter. Which graph shows the best line of best fit for the scatter plot?
I would actually go with C because it's more lined up at the bottom.
Yeah, I'll go with C too.
A little caution on this one. The temptation is to ignore the points that are way away from everything else. But in a scatter plot, we never do that.
Okay, so you're wanting to do a scatter.
These outliers will change the slope of this line. So don't make the mistake of thinking, oh, well, these all line up and ignoring these. Right?
We're not ignoring those.
Does that help?
Yeah. Yeah.
So would it,
Would you go with C, Mike? You're muted.
I'm muted. What did you say?
So
Would you go with C?
Yeah.
No, I wouldn't.
I wouldn't
No?
either. I wouldn't either. Scatter plots are more scattered information, but they are organized.
Right.
So I would go with either, I think I would go with D.
It starts at 5.
Actually, D ignores this upper point here.
Yeah.
Oh shoot, maybe I should move my thing. So
I
can
went
see
with
the-
A.
But A has the reverse slope.
Oh, yeah, that's true.
It's a decrease.
Okay, so I think B was my first answer. I'm gonna go with B. That's my final answer.
And that is what it should be, because we do need to include these outliers.
Okay.
This one just basically ignores them because this will tend to pull the slope up a little at the bottom. We'll pull this bottom up. This one will pull the top down. So that actually changes the slope a little bit.
Okay.
Okay.
I just researched scatter plots yesterday, so that's why.
Ah,
Good job.
Thank you. Kind of have to know the ins and outs of a lot of things when you're dealing with numbers, especially right now in algebra.
-3. I'm gonna go with A or C for 6.
Are you on 6 already?
Yep.
What did you say? Straight line Y.
Either A or C. I mean, the slope can be a negative, but it's a negative, then I'm doing something wrong.
Look at the signs. Remember, slopes can be negative. They can be positive.
Mm-hmm.
They can even be 0.
Yep. I feel like everybody just kind of took off on their own.
I'm still kind of lost, to believe it or not, so it's all right. I think my brain's just on overload right now.
So I kind of just subtracted 3 from both sides, which would be a -3.
Yep.
Because negative 2x.
I think you're right.
Which one are you guys on now? Are you on 6?
6, yeah.
Let me scroll up really quick. Okay.
This is not my week.
Girl, it's just been a busy, a chaotic week for me, so I hear you. It's my
This
week,
is
but
what I failed at in geometry.
oh,
This is not a good thing for me.
you're like, it's not good trauma. It's bad, bad trauma. Poor girl.
Believe it or not, I hate the geometry.
Do you really? But you're so good at it. I hate it, and I'm really bad at it. It's okay.
Yeah, I don't like it.
Geometry is way different than trigonometry.
I've never even taken trigonometry, girl, so can't even talk to you, right?
With my Algebra 2 class in high school, they had us do trigonometry for one of the semesters because everybody was so bored with Algebra 2.
You're like,
Like,
great.
half the class was falling asleep.
Can you help me with number 7?
I don't even know what 6 is, but sure, I'll try.
You don't know what 6 is?
No,
Oh, shoot, go back
they're
out.
all a possibility. A is slope, B is the diameter. No kidding. Ugh. So how would you do this, Mike? And you're still muted.
All right, you talking about number 6 now again?
Yep.
All right, go back to, let's take a look at this discussion of the equation of a straight line. Look at the form, mx plus b. M and b are both numbers. X and y are unknown. M and b can be either positive or negative. A positive slope is one that as you go from left to right, the line rises. A negative slope, as you go left to right, the line falls. They can both, and all you have to do is look at the sign. B is the place where the line crosses the y-axis. So if
I
you
just
look,
needed a reminder.
pardon?
Just needed a reminder.
Yeah, that's all. That's, and it's getting used to this. I mean, you guys haven't had to do these kinds of things, but we can calculate the slope or we can simply read it off a given equation. Okay, does that make more sense?
Yep. So it's B. Yep. Okay. All right. See, my brain is so slow today. I've been dealing with the temper tantrum babies this morning, and
Hmm.
That's never easy. takes a lot of patience.
Mhm. And also him wanting more milk, or he's hungry, or he wants to be outside. No, he wants to be inside. He's gonna throw a tantrum because we closed the door. Open it for him. He goes back in, we close it, he throws a tantrum. Can't win.
Is he
Believe it.
2?
Yeah.
Yeah, it's the terrible 2s, girl.
I feel like
It'll pass. It'll
No.
pass.
it'll go into tremendous 3s.
Believe it or
Well,
not,
you know what? It lasts all the way up till 4s. My kid was 6, you know what I mean? Till he got out of that phase.
Yeah.
So I feel you. It'll pass. Just patience and make it fun. Make it real fun, you know? Make it fun for yourself. It will mean, and then he'll know, you know. That's one thing I regret with my kids is not making it funner, more fun. You know, I always took them to the park and played with them and stuff. I was always that kind of mom, but, you know, I did play therapy with them, and that helped. Play therapy, you learn how they really are feeling inside as a person and not just how you want them to feel. This is how they individually feel as a little person.
Yeah.
Play therapy with him, and then kind of like experiment with his attitude. Is he happy? Is he angry? Is he playing in an angry manner? Is he, you know what I mean? You'll get to know your kid a lot better. You know, I know you know your kid, Anna, but you will get to know how to play with your kid better and what they're going through.
Well, he's supposed to be getting speech therapy.
Oh, he's probably very nervous. Play with him and see how he reacts to when he's playing. Just play with him. See how he's acting, and when he's acting like angry, be like, oh, you know, you're really angry right now, or, you know, oh, you're really excited right now. Just go with whatever emotion that he's explaining to you in his play, and he'll briefly try to get into talking to you about his emotion. But just observe that. I promise it's beneficial.
He doesn't string words together.
He doesn't have to strain. It doesn't have to be words, babe. It has
how
to be
old did you
emotion.
say he
It's
is?
emotion.
He's 2, and they're worried that he isn't speaking.
Boys aren't as vocal as girls as they're growing up.
Correct.
I don't know. I don't know him. I've just been around a lot of kids and raising my own and raising some of my grandkids. Boys and girls are different. Like my boy, well, I have one son and then and then I have 4 grandsons. So I have more experience really with the boys than I do the girls. But the girls, they were like super young and they could talk and they could tell you a whole sentence at 2 years old. But the
That's my girls.
the boys at 2 years old, they can make every animal sound and car sound imaginable, but they couldn't tell you a sentence. They could give you a choppy sentence and tell you what they wanted. But
That's why that's why it's beneficial, because the emotion is what tells you how your kid is feeling that day, whether they're going through stress and anxiety and anger or they're happy. It depends on how they're playing is what you want to observe.
Right.
And then you will get to know better how to interact and react to his issues. I promise it's beneficial, babe.
Well, you guys, I have got to get going so we can get ready for his physical therapy.
Okay.
I went ahead and finished mine and sent it in. So you guys have a good weekend, and I'll see you all on Monday.
Bye, Jen. I'll see you later. I'll text you.
Okay.
All right. Bye, hon.
I hope the appointment goes well.
Thank you. See you guys later.
Bye.
Bye.
But what's weird is that my cousins, all of my boy cousins, started speaking in full sentences around his age.
So you're going by your family's, you know, kind of heritage and their stages, but you can't, because we're all different, you know.
Yeah, I know that.
That's why I'm saying play therapy is the most beneficial thing for you and your kid. Emotionally attaching. Promise.
Yeah, you can't really do that unless early intervention is able to do it with us.
Well, ask about it, you know?
Yeah.
And when you ask questions like that, they're going to be like, wow, you're a good mom. You know what I mean? You know, you are a good mom. But just kind of like get those resources out there, and it will help you with your relationship with your kiddo a lot easier. Communication will be better. You will know your kid probably better than anybody else. I mean, you already do, but no one's going to be able to say, hey, your kid needs, because you're going to be like, I already know what my kid needs. You know?
Yeah, my mom tries to do that. I'm like, I know he's thirsty. He's also hungry.
Mom knows best, but that's why it's good for you to do that therapy, that play therapy. It will help you.
Yeah.
Especially because he doesn't talk a lot, you said. So my sons, they did not talk. So having therapy with them was like pulling teeth. And literally, I couldn't get them to talk. They wanted to play. So we did play therapy. And this is how we figured out their emotions and where they sat and what they were feeling that day, and how we could break it down and interact, not conversating, but interact with them.
Yeah.
Having a different kind of bond.
Yeah, I'm just kind of nervous for it.
No, it's fun. I'm telling you, it's so fun. And especially with a boy, it would be fun. I promise.
For question 8, how do we do this? You're on mute, Harley. And everybody just kind of conked out. Hang on.
No, we're all here except for Jen.
Yeah.
Think about this for a minute. We have x squared on one side of an equation, 9 on the other. We can do the same operation to both sides, right?
Mm-hmm.
So what we want to do is determine a value of x. So how do we convert x squared to x?
My brain is
You have
blank.
you have to eliminate the x square, right?
Yep. So how are you going to do that?
Oh, I don't know. You got to walk me through it again.
That's what
I know a
I'm
little about a lot, but not a lot about a lot.
So what is the opposite of a square? Mathematically, I mean.
I know I have these notes too.
us today.
My brain's hurting. So let me get my notes. Oh. I don't know. You might want to refresh us on this, because we learned this was week 2, right?
Yeah, we looked at this in week 2. We talked about the various operations. Remember, we have multiplication, division, addition, subtraction, and exponents.
So we have to
go either way, right?
Right. Do we have to subtract?
Well, there's a couple of things to think about. X, if we square x, we call it x squared, right? It's x times x. So we can take a square root of x squared and get x, right? So it's the opposite of, so they go both ways.
So are we square rooting both the x squared and 9?
Yeah.
Okay. X equals 3.
But there are 2 values. 2 numbers can be multiplied together to produce 9.
Yeah, 3.
And?
There's
3.
another number.
Oh.
1. Oh, just
Nope.
kidding. Just kidding.
What happens when you multiply a negative times a negative?
It makes a positive.
Right.
Oh, a -3.
Right.
You were close.
Yeah.
So 3 or -3 would be the
So
answer.
we've got both of those, plus and minus.
That's a lot easier than it.
That's a lot, yeah. Don't make it more complicated. we did not discuss a whole lot. What I really wanted to emphasize is that when we take a square root, it can be a positive or a negative number. There are two answers to a
Okay,
square root.
that's, okay, thank you for refreshing my brain, because that's what I was trying to read my notes on. But the two negatives make a positive, right? And then two
Right.
positives make a negative, or no?
Nope.
Oh.
No,
Always positives are positives.
not mathematically.
Okay,
Two positives, if you multiply a negative times a positive, you get a negative. But two positives make a positive, multiplied or divided, and two negatives multiplied or divided give a positive.
Is Angela okay? We haven't seen her for a week.
I don't know. I haven't heard from her. I'm a little concerned.
me too. That's crazy. I haven't even seen her on Facebook or anything.
Yeah, I didn't
That
get
makes
an
me
email.
worried.
So we'll be contacting her today to find out how she is. I'm a little concerned.
Because we haven't seen her for a week.
That's right.
That's a lot of stuff we've covered.
Yep. Yep. So I'm a little concerned that she's dropped off the radar.
Mhm.
Yeah, that's a little scary. Ah, my words not responding.
Okay,
I
so
just submitted it without my name attached to it. I hope you can.
yeah, well, if you just submit it to the submission box, it doesn't matter if you have a name on it or not. It's yours.
Yeah.
So you can do that or not. And later today, I'll publish a key for it so that it's there, just like I have the last couple of weeks.
Okay.
Okay,
The only thing we have now is the assignment and the assessment. Woo!
so we have about 45 minutes left of class. So I want you guys to work on your discussion, assignment, and assessment.
Mike, I need to reboot my computer. I need to restart this computer.
That's fine.
It's just
go
wigging
ahead-
out on me.
Yeah, just go ahead and log back in so that we know.
Okay.
you're
Have
still
we
in.
taken a second break anyways?
Yeah, you guys take a break. I'd forgotten about that because we got into this and because we got a
What was the answer?
Okay.
Oh, what was
take about a 10-minute break and then come back and
for 8?
go to,
It's
10 minutes.
-3 and +3.
right.
Because
Yeah.
there's 2 answers for the
Do it.
value
Do every
It's
quadratic.
-3 times
equation.
-3
Every
is positive
aquatic.
1.
equation.
Okay.
Okay, I'll see you guys soon. I'm gonna restart my computer.
Okay.
Okay, bye.
Was forgetting about the negatives. I can't help when I only think positive.
Well, we have to remember with quadratics that that you have 2 answers. And with something that is a square root, it's always a positive and a negative that can be the answers.
You're missing the joke there, Mike.
Yeah. All right. Well, I'm gonna stop recording or while you're working on the assignments. So take your break and come back, and then we'll work until about 12:15. All right.
Okay.